Conditional statements for this one. This is going to be your section 1.3 in Zybooks. So conditional statements come with different types of operations, propositions, statements, and hypotheses. So essentially a conditional operation is denoted with that symbol, which we've already looked at. It's basically the implied signal. So the proposition P, if Q, or P implies Q, or then it's read as if P then Q. We've actually seen a few of these earlier, so this is going to be more like a revision plus a couple of new concepts. Conditional proposition is going to be, it's a conditional operation which gets used in a proposition. It's a compound proposition which has a conditional operation in it. Conditional statement, it's again in English language explicitly, it's basically a conditional proposition. So long as you speak it, if I say something, so for example, if I say something, then it becomes a conditional statement, is basically a proposition which I'm changing and making into a conditional statement. A hypothesis is essentially, again, in P, if P then Q, the proposition P is your hypothesis, which is again you're just assuming something, and then the proposition Q is the conclusion, which is what you're trying to prove. So in if P then Q, your proposition, or you have your truth table, which you have basically for conditional operations. We've already done this. So if you look at a conditional statement, for example, if you mow Mr. Smith's lawn, then he will pay you. Take the first thing to be P. The he will pay you is Q. Basically, that's the conclusion. So now you have two different conditions here to be met. One, you mow Mr. P's, one where P is true, and you mow Mr. Smith's lawn. So P, if P, then Q, if that's true. And in this case scenario, Mr. Smith does not pay you. So you're creating a truth table where you're mowing Mr. Smith's lawn, you're not mowing Mr. Smith's lawn, Mr. Smith pays you, and Mr. Smith does not pay you. So the only condition in which this whole truth table becomes false, or the contract gets broken, is when one is true and the other is false. So essentially your hypothesis is true but the conclusion is false. That's your conditional statement. Now you have different English expressions of your conditional operation. So let's say you mow Mr. Smith's lawn and Mr. Smith will pay you. So now think about this in English language, right? If P then Q. So if you mow Mr. Smith's lawn, then he will pay you. If P, Q. So if you mow Mr. Smith's lawn, he will pay you. There's no then here. Q if P. So Mr. Smith will pay you if you mow his lawn. P implies Q. Mowing Mr. Smith's lawn implies that he will pay you. P only if Q. So you will mow Mr. Smith's lawn only if he pays you. P is sufficient for Q. Again, mowing Mr. Smith's lawn is sufficient for him to pay you. Q is necessary for P. Mr. Smith's paying you is necessary for you to mow his lawn. These are all English expressions, and this is how you would be defining them if we decided to go with essentially English expressions. Now the converse of this would be Q, if Q then P, or Q implies P. The contrapositive, on the other hand, just negate both sides. So negative Q, if negative Q, then negative P. Inverse, again, the inverse of P, if P then Q, is if negative P, then negative Q. So keep this table in mind. Then based on that, if you can have different converse statements. So Q, if Q then P, becomes if the game is cancelled, it is raining today. So when you have, and this is when the proposition is it is raining today, the game will be cancelled. Now the contrapositive for that is negate your Q, negate your P, and then they have to work together. So if you negate the Q, essentially what you see happening is if the game is not cancelled, then it is not raining today. Inversely, if it is not raining today, then the game will be cancelled. Now, biconditionals are if and only if statements, which is, again, we've seen this before. So, if and only if P, if and only if Q, which is denoted as that. And IFF is your abbreviation for it. And the truth table for your biconditional operation is basically this. So, if it's both true, you're going to see true. If it's true, one is true and the other is false, it becomes false. One is false, the other is true, same thing, it's going to remain false. But if both are false, which means both are negative of what we're trying to prove, then it becomes true. That's everything you need to know with conditional statements. Thank you.